2006 turnaround after implementing a leak management program. First, we developed a critical joint list. This list included the known historical problem leakers that we knew of from the previous run, and also included joints that were selected using a risk-based criteria, similar to what Ed talked about earlier. We also established QC oversight of the contractor. This QC involved reviewing the turnaround contractor's procedures, training and qualification programs prior to the turnaround. We had our QC oversight independently verify the procedures for torque retention that the contractor was going to use. This included review of the torque retention value itself and made sure it was adequate to achieve the preload required. Then we documented the disassembly condition of the critical flanges, which included a number of things such as whether there was any evidence of a leak, any corrosion, steam cutting, scale or deposit, pitting, cracking, distortion or misalignment, fire damage or warpage, basically any mechanical damage. Then we documented the reassembly procedures used, which included things such as target torque, retention value, lubricant used, K-factor used, whether washers were used, and we verified that the flange was made up properly with the correct gasket and material, proper bolting, good alignment of flanges, and so on. And with our QC oversight, we had consulting expertise on site that could provide training to the turnaround contractors as needed. But ultimately, our QC oversight was not there to take the job away from the turnaround contractors, but to ensure that the procedures that we developed prior to the turnaround were followed and implemented correctly. This next slide shows a detail of some of the flanges that would have made our critical joint list because they had leaked during the previous run. As it says, we identified 28 joints that had leaked previously. These were the no-brainers that got put on the critical joint list, obviously because we had leak problems with them in the past. As I mentioned earlier, we then used a risk-based criteria similar to what Ed talked about to weed through the rest of the flanges in the plant. And by using this risk-based criteria, we identified 270 plus additional flanges to put on our critical joint list to receive special attention. So here are some of the results that we obtained by implementing this leak management program at NCRA. The plant restarted with a record number of non-leaks. Typically after startup we hear several leak problems from our operations people. We didn't seem to have these problems or hear much from operations regarding leaks on this startup. One specific example that shows the success of our efforts is a recent power loss we had in February of this year. The entire refinery lost power for over half an hour, and feed and circulation was lost in the units. In the past, this type of event would have guaranteed leaks in some of the units. However, we experienced no reported leaks due to this power loss. And this is a major compliment to the leak management program. We also established a leak tracking database that holds all the information documented on the critical flanges at turnaround. With this database, we can begin to develop a history of the critical flanges in the plant and how to properly treat them. Ultimately, the desired result was to reduce the number of leaking flanges to improve both safety and profitability. And so far, we feel that we have accomplished this at NCRA by implementing this leak management program. Now I'm going to hand it over to George Sturdivant with Fast Torque.
Thanks, Von. We were very fortunate to be involved with NCRA on the program that Von just discussed with you. And we have subsequently looked over all of the preparations that were done, and
hand it over to George Sturgeon.